So the simple model of the atmosphere you're given is that it's a pressure gradient that goes from atmospheric pressure of 1 bar at ground level all the way up to the vacuum of space. But the reality is the atmosphere is not one big lump of air that extends into space. The chemical composition, the temperature, the density of the atmosphere all changes with altitude. And broadly speaking, it fits into layers, because as layers change, different forces have different acts upon it, and it changes how it behaves. Each layer is separated by what's known as a pores. So at the top of the troposphere you have the tropopores, at the top of the stratosphere you have the stratopores, and so on. And these can be quite abrupt, or they can be quite broad, quite nebulous layers between these different areas of the atmosphere. So let's start with the bottom of the atmosphere, the troposphere. And this is the part of the atmosphere we live in, and it extends up to about 10 to 12 kilometers. It's a little bit thicker at the equator than it has at the poles, but generally speaking, around about 10 to 12 kilometers. It's where all the breathing happens, and even then, it's mostly the lower part of that is able to support life. You can still breathe up to as high as 20,000 feet or 6,000 meters, but beyond that, your body starts to find it increasingly difficult to get sufficient oxygen in. And once you get past 8,000 meters, you're into the death zone, because this is where your body starts to shut down, no matter how well acclimatized you are. High altitude climbers do attempt brief periods in this altitude without oxygen, but it's incredibly dangerous. Being above 8,000 meters without oxygen, like climbing Everest, isn't recommended for more than 20 hours absolute maximum, and that's for professionals. Most people succumb to hypoxia through altitude sickness well before reaching that altitude. It's also worth noting that at 6,000 meters the atmospheric pressure has already dropped from the sea level average of 1013.25 millibars down to 500 millibars. So half the weight of the entire atmosphere is in the first 6 kilometers from the ground. And this is partly because that's where by far the majority of the water vapour is, but also because gas is compressible, so it's more compressed at the bottom due to the weight of the atmosphere above it. So that's why the atmosphere is in a logarithmic pressure scale. There's a lot more of it at the bottom than there is at the top. Now, how much water and in what form it's in depends on the temperature mostly. Once you get below a certain temperature, broadly speaking, the colder air is, the less water it can hold. And if air moves from a lower, warmer layer up to a cooler, higher layer, it's sufficiently humid, it'll reach a point where it can no longer hold the water as vapour, and it condenses into tiny droplets that we call clouds. And this can be a pretty sudden transition at what's known as the lifting condensation level, which is why clouds have a fairly flat bottom but rough and lumpy on top. LCL and dew point are kind of similar, but caused by different things happening. I can get into that another time, but essentially LCLs are when warm, humid bodies of air rise up and expand, which causes its pressure and temperature to drop, and it makes its saturation point lower. This makes the water condense from the air into tiny droplets, and when they're small enough, the updraft pushes them back up into the air faster than gravity's pulling them down. But while this is happening, they collide with other droplets in the air and they become bigger. And once they get too heavy for the updraft to push upwards, gravity does its thing and they fall as rain. At the very top of the troposphere, the air is so cold it can barely support any water, and it's almost 0% humidity. Not quite, but almost. And this is the first transition, the tropopause, and it marks the change from the troposphere to the stratosphere. And at this point, the air pressure is down to about 200 millibars. Still survivable without a pressure suit, but not without oxygen delivered under pressure. So, to sum it up, the troposphere is where all the breathable atmosphere is. It's where most of the weather happens, because it's where most of the water is, and it contains more than about 80-ish% of the matter that is in the atmosphere, and that's all in the first 12 kilometers of atmosphere.